So today we're starting equivalent fractions, and we need to know that equivalent means equal to or same as. So if you hear somebody say equivalent, it means that something's equal to or the same as something else. Means the same thing. Same, equal. All right, we're going to look, I'm going to go down the left side first, and then we're going to go down the right side. So if you see that big old model here, we're going to fill this in together so that you can see, it's like fraction strips. You're going to see how one whole is equal to all of these different types of fractions and how some of the fractions are equal to other types, okay? So I'm going to kind of highlight them once we're done, but I'll point them out to you as we are going along. So the first fraction strip that we're looking at is 1/2. And if you take 2 halves, they equal 1 whole. And then I have 1/3. And if I have 3/3, they are equal to 1 whole. Then I have fourths. So if I have 2/4, look what these 2/4 are equal to. 2/4 are equal to 1/2. But 4/4 is equal to 1 whole. The next one is broken up into fifths. 5/5 is equal to 1 whole. The next one is broken up into how many parts? 6. 3/6 is equal to 1/2. And 6/6 is equal to 1 whole. The next one's broken up into 8 pieces. I'm going to show you the equivalent fractions. There are 8 pieces. So 2/8, if I look straight up right here, 2/8 is equal to the same amount as 1/4. And 4/8, this right here, is equal to the same as 2/4, or also 1/2. And then if I have 1, 2, 3, 4, 5, 6/8, all of this, it is equal to the same amount as 3/4. The last one is broken up into tenths. There are a lot of equivalencies for tenths as well. You'll notice that 2/10 is the same amount as 1/5. 4/10 is the same as 2/5. 5/10 is the same as 4/8, which is the same as 3/6, which is the same as 2/4, which is the same as 1/2. Lots of equivalencies there. This right here, I have 2, 4, 6, 7, nope, 6 right here. 6/10 is the same as 3/5. 8/10, this whole section here, is the same as 4/5. And then 10/10 is the same as a whole. So you can see a lot of our equivalent fractions right there. Okay, any fraction times 1 is equal in value to the original fraction. Think about that for a minute. If I have a number times 1, it's equal to the number that I started with, right? Okay, so same thing with fractions. Any fraction times 1 is equal in value to the original fraction, even when the whole is broken into different parts. So think about a pizza for a second. If I have a pizza, it's a whole pizza, and I cut it into 4 pieces, and then Brock eats 2 of those 4 pieces. Would it be the same as having another whole pizza, cutting it into 8 pieces, and Chase eating 4 of those 8 pieces? Is it the same amount? Yeah, it's the same exact amount. It's just broken up into different parts. That's what this section that we just did here is explaining. I accidentally undid that. Okay, so we're going to go down and we're going to look at what this looks like. Remember, any number over itself is 1. What does that mean? It's an example right here. 3 over 3 equals 1. Any number over itself, so 3/3, 5/5, any number over itself is equal to 1. Okay, so let's look at all of these models for an example. The first one is showing what? 1/2. So if I take 1/2 and I multiply it by 1, it's going to still equal 1/2, right? Okay, well, 2/2 is also equal to a whole, but it's going to look different. It's going to look like this model here, 2/4. So did you notice how I took 1/2 times, now I'm multiplying it by 2. So 1 times 2 is 2. 2 times 2 is 4. That gives me this fraction here. It's the exact same amount. I've just changed the number of parts that I now have broken my model into. So then 2/4, this is a 2, that looked weird. 2/4, if I'm going to increase it by 2 again.
Teachers, please excuse this interruption. I did want to make a very special announcement.
Okay, so I have 2 times 2, which is 4, and then 4 times 2, which is 8. I'm just increasing it. I'm doubling the amount of squares when I multiply it by 2, but 2/2 is the same as 1 whole. So all of these are still equal to 1/2. They're just broken up differently into different amount of parts. Okay, so what did you notice? If I multiply 1 times 2, did you notice that I also did the same thing to the bottom? Yeah. Same thing here. 2 times 2, and then 4 times 2. I had to multiply by the same number.
Well, that makes sense.
So when I look up here at the top right, because we're going back up here to the top right now, it says always multiply the same number to the top and the bottom. So if whatever I do to the top, I got to do to the bottom, which is why it's all going to be, if I multiply the top by 3, I multiply the bottom by 3. Why? Because it's equal to 1 whole. It's like multiplying by 1. If I multiply the top by 4, I got to multiply the bottom by 4. Why? Because it's equal to 1 whole. All of these are equal to 1. You're not changing the value of it. You're changing what it looks like. How many parts from the whole. You're changing the parts in the whole. That's it. Okay, what does it look like on a number line? Well, this number line is broken up into 1, 2, 3, 4 total parts. How many of those total parts are selected? 3. Okay, so I know I have 3/4 for my first one, but the second number line is broken up into how many parts? 12 total parts. How many are selected? 9. Okay, I want you to look right here for a second before I plug in 9. What did I do to 4 to get to 12? I multiplied by 3. Well, if I do that to the bottom, I have to also do that to the top. And so I can see that 3 times 3 is 9, which is the same as this. Whatever you multiply to the top, you have to do to the bottom. Okay? Let's look at another different type of model. This time we have circles. I have 4/8 and 2/4. They're the exact same amount. This is like a great example of the pizza, okay, because pizzas come in circles. 4/8 is the exact same amount as 2/4. Doesn't really matter how you break it up. it's still the exact same amount. I'm still looking at overall 1/2 of that circle. Does everybody see that? Okay, so down here, we're gonna show that 2/4. What did I multiply 2/4 by in order to get 4/8? 2 and 2, 2 over 2, which is 1 whole. Okay, we're gonna do a little bit of practice. We get out of here in about 15 minutes. So I am going to pass out your practice to you. You are gonna stay at your table, but you may help each other at your table if you need it.